All right, so my name is Zooey, and I'm a student at Johns Hopkins University. I'm studying mechanical engineering there, and I've been the intern at Mack Trucks, so over in LVO, for the past 2 months now, and I have a project that I'd like to present to you guys real quick. So my solution is called Trace Solution, and it deals with the repair stall area as shown in this picture at Mack Trucks. They really don't have any organization right now in that area, so I'm actually working on a way to help them track everything through the repair stalls. So a little bit of background about the whole entire process there, right? Are you guys familiar with the assembly line or anything? Okay, cool. Then oh, okay. So it's a similar process. So all the resources and all the parts for the trucks come into the Mack truck plant, and what happens is 130 trucks a day start the assembly process, so start at the beginning of the assembly line, and 60 trucks go through without any issues at all. 70 of them have some sort of defect associated with it. It's either a defect or a missing part usually, but what happens is those trucks get parked in this queue we call the float, and as of a few weeks, I think last week, we have 700 trucks in our Mack Trucks float. So that's a pretty high number, and we'd like to keep it around 200, which is actually the number we're aiming for. 558 of those trucks are late. So these trucks all incur fees, and a lot of them are about $1,000 a day for a week, up to a week that it's late. So it's a lot of money that builds up in the meantime. We also have 38 repair stalls at Mack Trucks. They're specified for different types of repairs, and they process 55 trucks a day. So we then transfer 55 of those trucks out every single day. And all these trucks that do get finished get shipped to the customer. But you can see there's a deficit. There's 70 trucks that come in and 55 trucks that leave. So there's a deficit between that. And what we do is we make that up in overtime, which is more cost for us as well. So I'm using a Internet of Things technology and also a computer vision technology to try to resolve this issue. And I'll show you my solution in a second, but unfortunately, there's some technical difficulties. We crashed, we dropped the camera, so it's not 100% working, but I can show you everything up to that process. So this is a repair stall. So everything in my system is set up in a repair stall. So a truck enters a repair stall, and what we do is we're going to attach a QR code onto that truck. We have the capability to do that already, and we just have to implement that. The same system that prints out the model chassis number can print out the QR code easily. The truck's entrance is detected by a sensor. The sensor is a distance sensor, and within a certain distance, so if it's placed in the front of the stall, within a certain distance, we'll say that the truck is in the stall. Then we're using a Raspberry Pi camera. So that's a camera that comes with the microcontroller called the Raspberry Pi. Are you guys familiar with that? Okay. Not really, I'll talk about it in a second. So yeah, the Raspberry Pi camera is attached to a motor mount, and that allows us to scan the windshield of the truck for the QR code. The QR code has 2 bits of information in it that helps us identify what truck that is. So each truck has a model number for its type of truck that's being built, and also a chassis number, which is unique to every single type of truck that goes through. So with those 2 pieces of information, we can pretty much find what truck we're working with. So with that information, what we do is we query a Microsoft Azure database to get information about what types of repairs need to be done, and we load that information into a touchscreen for the operator to use. So this whole entire system will help us with 2 things. One, organization in the stalls. It will allow us to quickly, list out all the repairs. Right now they do it on paper, so they have a stack of paper about that thick and stapled together with an industrial stapler. So it's pretty bad there. Their system is very inefficient. So they flip through everything to figure out the mistakes, and we just want to have that all in one place. And yeah, so that's the first goal that we're trying to accomplish. The second one is to do analysis. So my system will track when each repair starts and when each repair ends. And then using that, we can find some average data, as well as start implementing some machine learning, which I'll talk about in a second as well, to produce more intelligent analysis and statistics for the management team to actually start scheduling. Right, that's the second part. And then the last one is also to track the trucks through the repair area. area. So every truck that enters and leaves will automatically be picked up by the system without any user input. That means that there's a live map. We have a live map on the database that shows where the trucks are in what stall and how long that truck's been in there, as well as if it needs extra help or not. So there's a get assistance option as well. Right, so these are the instructions that we're collecting. We're starting with core instructions. So that is a category for us. That's a repair category for us. Along the lines, the truck has to go through about 100 different core instructions, right? So they're step-by-step processes that the truck has to go through in order to be completed. So one of them could be put a door on, screw this bolt in, or different processes like that. And when there's an error, I have a system to input this information into that database. So let's say with that screw, it's not tight enough. You'll put that core instruction in that form and extra remarks and anything else you want to add into it, and then send it to my database so that's all in there. Also submission time, so when that error was submitted, the planned production end date, so that's when the truck is due. The model chassis number, as I said, is what's associated with that truck. The repair start and the repair end, which I'll show you how we collect in a second.
Here's what this looks like right now. This is data taking.
So I'm using Microsoft Azure as my database. It's very versatile and also offers a lot of tools for us to do analysis. You can build your own applications on there. You can build your own programs to do analysis, machine learning, and everything is built on that database. So it's a pretty comprehensive, and it also allows us to have a user interface as well. So that's actually the next point, user interface. We have an app that we're in the development process of to display all this information. So it'll be the repair averages as well as a live map to what's happening everywhere. It's going to be really helpful, even if one of them doesn't work. If just having each one individually is a huge benefit for them, since they have no idea what's going on at all. And we'll automate the data collection process as well. And then the Raspberry Pi, which I mentioned, is this microcomputer. We'll upload to the Azure database. The Raspberry Pi is pretty much a computer. It does everything a computer can do. So it's a really good tool for doing a lot of these kind of projects. Right, so in addition to just scanning the QR code with the camera, there's actually a little bit more technique involved with that. A lot of times you can scan right away, and those are the good ones, right? Those are about 80% of the time you can just go and scan it. So when we set it up in the stall to trial run, that's about 80% of the time. But there's also 20% of the time that we could identify it, but can't read it. And we identify it using computer vision. So computer vision allows us to track certain shapes in different pictures, right? And there's a software out there called BoofCV. So it's BOOFCV. For computer vision, and that software allows us to identify QR codes, even if they're slanted, upside down, different shape, slight reflection, shadows, anything to identify a QR code. If it can read it, it'll read it for us. But there's a good chance that it's too slanted, or the reflection's too bad, that it's a little bit too difficult to read. It can still identify it. So in this case, they put a red box around it. This is an actual image from that, if I could get it to work. It identifies the object, but it doesn't actually allow us to go through and find the individual, read the actual QR code. So what we do from there is we get the parameters of it, and then we put a dot in the middle of the QR code by using the coordinates of the corners, right? And this is all in units of pixels based on the picture, right? And then what we do is we move the center of the camera, which is this blue dot right here, and towards the QR code by using our motors. And so actually, after we did the correction process, we got something that looked like this. This is a demonstration at my desk. It's not in the stall, but we got an image that is closer to the actual point we're looking at. So this allows us to optically zoom in on it and potentially catch a few of the ones that we couldn't catch if we just took a picture of it. Right, so that's the general idea of my solution. I'll show you a quick demonstration. Unfortunately, can't do the camera part of it since we did, have to replace it. But I can show you real quick what we have going on here. Here, let me just turn this over a little bit. All right. Okay, so no, we're still going on. Yeah, so right here, this is the Raspberry Pi camera, right? This is the system that we're dealing with, right? So this whole thing will be set up in a repair stall. And it starts with employee entering and typing up his employee number. We can offer some validation that way, and also not any random person can go in and alter our data. So if you go in and we can type in some number, right? So it's initially trying to set up right now, but since there's no camera attached to it, there's really no purpose. It starts in an initial position, and it uses this laser sensor to sense a distance. So right now, since I have my hand in front of it, it's going to go down to a low number, 1. So after 5 iterations, what happens is it triggers that to start looking for the QR code. But since we don't have that set up, unfortunately, we can't demo that. I can manually enter that information instead. So if all else fails, we can always have manual entry. So if you click Start a Repair, 1 second. Yeah, and you can manually enter your number. So this one, the one that we're working with this QR code is actually 907-2056. And if you click Set, what happens is it pulls all the information down from the database that is related to this truck. And the ones that have timestamps, you can sort by timestamps. If you just tap on that, you can see all the ones that don't have timestamps. But the ones that have timestamps are the ones that have been done already. And then the remaining ones are the ones that haven't been done. So then the operator working on the system can really quickly go through and see which ones he can do. You can all come closer to a little bit if you want, but it sorts it by different categories. There's a core instruction here that identifies that, and if you tap on one of these and click Finish Repair, what it does is it actually puts a time next to it. And the starting time is when the truck entered, and the ending time for that repair is when I just tapped that. And then this way we have a start and end time to find the duration and calculate some averages for the management team. And this, as I mentioned, this also updates the information in that table to stall status, which shows us what trucks are in what stalls at what time. In addition to this, we're actually looking to apply some machine learning on top of this. So once we have enough data, we can start training some machine learning models to allow us to identify what repairs go together. So there's certain repairs, like if there's 4 engine repairs, right? You only need to take the engine out once. You don't have to replace it every single time. If you have those, then you want to group those 4 together because they're a shorter amount of time. So then we can find the relationships between different repairs if we start looking at it that way. And how we do that is we collect groups of repairs instead. So this right now collects individual repairs as a baseline, but in the future we want to collect, let's say A, B, and C took 2 hours, and C, D, E took 4 hours, and you have a bunch of these combinations of different repairs. You can actually go back through and sort it with machine learning to figure out, in the future, if we have these 3 repairs in this order, how long will it be predicted to take? And that will include the connectivity between them, so whether one repair time affects another. So that will be a much more comprehensive solution for the management team in terms of scheduling, and will allow us to, in the future, create some scheduling programming instead of just giving people paper. And also, even with this process, they'll have a better idea of how to deal out the different repairs. If you get a chance to later, go check out his project as well. His project deals with finding the trucks in the float, so the parking lot, and using a drone. So our projects will feed into each other. And hopefully we want to collect everything in one database so that we can actually go back in the future and do a lot of analysis on it and generate some more meaningful data for everyone. So.